Hi, everybody. Welcome to our Vulkan Validation Layers Deep Dive webinar. I'm Kathleen Matson. I'm the Director of Marketing for Khronos Group. And I just wanted to go over a couple of things before I turn this over to Carl Schultz of LunarG to do our presentation. We have built in plenty of time to answer your questions, and we hope you have lots and lots of questions for us. What we're going to do is answer those questions at the end of this webinar. You'll notice in your GoToWebinar tool, near the top of the screen is a question mark icon. If you click on that, it'll bring you up a little interface where you can type a question. And again, we'll go through those questions at the end of the webinar and read the answers. We are shooting a video of this. We're recording a video. The video of this webinar, as well as a PDF of the presentation, will be available on our website for you to download. An email will go out to you after this webinar that gives you the link to that. So you don't have to worry too much about taking screenshots or writing notes. You can just enjoy the webinar. All right, so with that, I will turn this over to Carl, and he will do our presentation as soon as I unmute him so that he can actually speak to us. All right, Carl, it's all yours.
Okay, Kathleen, thanks very much, and thanks to everyone else for attending this webinar. I'll just get the agenda up here on the slides, and as you're looking at that, I've got a couple of points. The intended audience for this webinar is really anybody who's interested in learning more about the validation layers. The first few sections of this talk will cover, why the validation layers are used and how to use them, and we're going to cover this with a little bit more detail than we have in past presentations. But Khronos has also heard some feedback from previous webinars that they'd really like the webinars to have a lot more technical detail than previous webinars. So if there's ever a place to get what you asked for, this webinar is going to be it, because we're going to dive in really deep, go into lots and lots of detail. We'll talk about each layer, how each layer works. We'll look at some code and just show you how it all comes together. Then we'll finish it up with a quick look at where we think the layers are going in the future. And as Kathleen said, this webinar was originally scheduled for 6 minutes, and I timed out the slides, and they really take about 50 or 55 minutes to complete. So if you could really only stay for the first hour, you'll probably be in pretty good shape. You'll get to see most of it, but hopefully you'll stick around and listen to a few of the questions and answers. So the basic Vulkan application architecture. This is a slide that I saw at SIGGRAPH this past year, and I apologize, I don't quite remember what presentation I saw. It wasn't this exact slide, but it was one a lot like this one. I really liked it because I liked the message that it presented. So this is a comparison of OpenGL and Vulkan application stacks. So the application development process is a little bit different between OpenGL and Vulkan. With OpenGL, the OpenGL driver is always checking for errors, and this error checking is really built into the driver and really can't be turned off easily. This red box, the purple box, this validation code is really intertwined into the OpenGL driver pretty thoroughly, and it's difficult to, you really just can't turn it off or anything like that. And so the code in is really all the extra work that the driver must do to use the hardware correctly and try to prevent GPU hangs and things of that nature. Things are a little bit different with Vulkan. In the middle box, the validation code is separated out into a separate layer. And what you should do is during development, you want to make sure your application is validation clean, which means that it runs without triggering any validation errors. Finally, when it's ready to be released, over in the right-hand box, you can just eliminate the Vulkan validation layers and just ship basically the application and the driver. And the result is you've got a much smaller footprint, but you're also not that validation code over and over again, because once you've validated your application, there shouldn't be a lot of need to to do validation continuously after that. This slide's a picture of the Vulkan application stack, kind of a closer look. At the very top, we have the Vulkan application. And I've got a box here for the loader, and we're not going to talk about the loader in this presentation very much because it's really a topic that we could do another entire webinar about. So it's a big deal. It does a lot of things. But I wanted to point out that it's in the stack because it loads the Vulkan driver that you see at the very bottom, and it also loads the validation layers. Right now there are 7 validation layers represented by the yellow boxes, and they're kind of all grouped together into a logical collection called the standard validation layer. And a couple of notes about each layer. The threading layer that you see at the top is supposed to check for it checks to make sure the objects aren't violating threading restrictions. Parameter validation is kind of what it sounds like. It's stateless API parameter checking, kind of simple checks to make sure that pointers are not null when they're not allowed to be null. Object tracker keeps track of object lifetimes, making sure objects exist when they're supposed to exist. Image is sort of a focus area. That particular layer just concentrates on image checking for items that are related to image generation and usage. Core validation is the main validation layer. It does draw state checking, shader checking, memory tracking, device limit checks, and swap chains. A lot like image in that it's just another similar layer that focuses on swap chain related items. It turns out that, and we'll talk about this more later, the swap chain layer and the image layer really do the same things core validation does. They just happen to be separated out into different layers, and they'll eventually be combined into the core validation layer. And then finally, we have the unique objects layer that remaps object handles to guarantee that handles are unique, which makes it easier for the layers to process that. So why do we use validation layers? There are basically 3 major areas. One of them is correctness, and here you see the famous black screen that happens when something goes wrong. It's we've all seen this as graphics programmers at one time or another, and sometimes it's pretty hard to figure out exactly what's wrong. In particular, in the Vulkan case, we don't have a lot of error mechanisms, really no error messages. We do have VK results, and in this case, they may all come back okay, and we still get a black screen. So, what's wrong? And so one way to go about debugging this is just to turn on validation layers. And when you do that, you'll get a message something like this. It's very, very clear. It's saying, hey, you forgot to call end command buffer, which, of course, closes the command buffer and takes it out of recording mode. And you have to do that before you submit the command buffer onto the queue. So it's really easy to fix. You go in and fix that problem, and voila, your application starts working again. Another reason to use validation layers is portability. The Vulkan API itself is considered by many people to be very portable because the API itself can be implemented on a wide variety of platforms. But this aspect of portability doesn't really translate directly to applications. In fact, it's actually harder to write applications and keep them portable across this many devices. And the point is the validation layers helps you write applications that run correctly on many devices. If you're doing all your work on one particular device, your application might work okay, but if you turn on validation layers, the layers may warn you about things that won't work on other GPUs once you take your application over there. And finally, efficiency is another reason to use validation layers. The layers themselves don't make your application more efficient. Certainly removing them or not using them makes the application run faster, but that's not a reason for actually using the layers. But some layers actually do give you some performance warnings that you can consider as tips for your application. But really the main thing is the flexibility in the layers, that you can get the validation work out of the way during the right time in your application development and deployment. At some points you'll want to run validation a lot, but once you've got your code all figured out and things are working pretty well, you can turn off layers completely, you can leave some of them on. It's just a really flexible system. So if you really don't take away anything else from this presentation, I'm kind of hoping that you'll take away this idea. Basically, the Vulkan validation layers are to applications as Vulkan Conformance Test Suite is to Vulkan drivers. So basically, use the Conformance Test Suite to validate drivers, but we should think equally, or give equal priority to and attention to using the validation layers to validate applications. And hopefully that will convince you that hopefully that will convince you that validation layers are a good thing. So how do we use these validation layers? So then over the next few slides, we'll talk about the standard validation layer and also a couple ways to enable the layers and how to control the layers. And then finally, why turning on and how to turn on only some validation layers. The standard validation layer is a sort of meta layer, I call it. It just simply loads these 7 layers in the same order each time you use it. So that's convenient because it makes it a lot easier to load these layers. You don't have to enter 7 different layer names. So it's just a convenience item. It also protects you against changes in the layer list. I mentioned before that we might be combining image, core validation, and swap chain together, and if that happens, if you just continue to use the standard validation layer, you'll pick up those changes automatically. You won't get errors like, oops, the image and swap chain layers can't be found. But instead, if you just load the standard validation layer, you don't have to deal with that. So one way to activate layers is through the use of environment variables. This is very easy to do because there are no code changes involved, and all the layers are configured. These 7 layers that are part of the standard layer, they all send their messages to standard output by default. So using the layers is slightly different depending on the OS. If you're running on Windows and you've got the LunarG SDK installed, the installation process for the SDK sets the registry up so that the Vulkan loader can find the validation layer binaries. It's a little bit different on Linux because Linux systems tend to differ a lot from each other and in how things get installed. But if you install the SDK for Linux and set the VK layer path environment variable, that helps the loader find the layers. And there's other things you can do, like putting the layers in system libraries and things like that, and all those details can be found in the Linux Getting Started guide in the SDK or on the Lunar Exchange website. And also, we'll have links for the place where you can find the SDK and the Lunar Exchange website on the last slide of this presentation. So we'll give you the URLs on that slide. So that's finding the layers. To actually activate them, you would set an environment variable that lists the layers that you want to turn on. So in this case, if you want the standard layers, you just set it like the slide says. So here's an example of activating a layer at a shell prompt. This is just a Linux box, and I've got a copy of the Cube application that has the same mistake in it that we looked at before. It was missing a call to end command buffer. So I ran the Cube and nothing happened. Got the blank screen. So I said, okay, let's turn on the validation layer. And so I export that variable. And then I run the Cube again, and the --C10 just says draw it 10 times, so we don't get a flood of messages, and we get the same error code. So that tells me what's wrong. So that just shows you how simple it is to turn on a validation layer. Another way to do it is programmatically, which is probably better in the long term for an application that's going to have some, hopefully some success and some lifetime. And it's pretty simple too. You just create a list of layers that are just text strings and the number of them. Yeah, let me get my pointer back out here. Sure. And then so you set up the list of layers that you want, and then set that in PP enable layer named, the layer names, and also the count in this case, which is just 1. Okay, and then just a tip: if you expect to turn validation layers on and off a lot, it's probably easy for your users and your testers, etc., to have an application option that sets up the layers programmatically. So the Cube demo is a good example. You can look at the source code for that. You can find that in the SDK as well. And it has a feature where you can just say --validate, and it will spit out the validation errors if there are any. So it's easier on your users, so they don't have to hack around with the code or set environment variables. If you have a tester, you can send them an email that says, hey, what happens if you turn on validation? And you can tell them how to do it. It's real simple. Okay, for as far as controlling layers go, I'll show you a couple ways of controlling them. One is this layer settings file, and you can use this to control what action to take when a validation error occurs, and also where to direct the message output. You can find a sample file in the SDK in a directory called config. That's true for both Linux and Windows SDKs. And you can also see here on the slide what a default settings for one of the layers look like. So here we're looking at core validation. I think all the layers have the same default settings. So basically they are going to log a message as far as the action is concerned. The severity is represented with error warning and perf, and the default output is standard out. And if you wanted to, for example, send the output to a file, you just replace the file name with a real file name. So this file, the layer settings file, if you want it to take effect, you put it in what the current directory is when you launch the application. And take a look inside the file for a lot more information. The file's pretty well documented, and there's a lot of detail and information in there about what else you can set inside the file. Another way to control the validation layer behavior is with the debug report callback. And you would use this if you need a lot more control. And it's probably, again, a good thing to implement in your application if you're going to be working on an application for a long time, because this has a lot of power and a lot of flexibility. So because it's code, you can basically do whatever you want when it gets called. You can analyze the incoming messages to decide what to do based on severity and the type. You can even look at the text and say, I don't need to pay attention to this one, or I'm in big trouble if it matches something that is a problem. Lots of stuff you can do. One key and kind of hard to understand feature of this is the callback and return true or false. And if you want to, for some reason, have the driver or the layers below a certain the validation layer that's reporting the error, if you wanted that layer or the driver to skip the API call, you would return true. But if you want things to just continue on, normally you return false. And it turns out in most situations you want to return false, which is a little counterintuitive, but in a lot of cases it makes sense, because if there is a big problem like a crash, you want the crash to happen close to the point where the message is generated. So the valuable thing here is that you get a message that tells you what's wrong. And if there's a crash a little bit later, well, that's okay, but because you're going to fix the problem using the clues from the message. So here's an example of debug report callback. This comes out of the cube example. I've tweaked it a little bit here so it fits on the slide. But in general, let me get my pointer out. Up here near the top, we take a look at the message flags that tell us what the severity of the message is. So in this case, for the error message, we go ahead and format the string the way we want it. And then we look at this code here in case it's a warning. And the default case is, well, if we format the message too, but we also check to see if it's a specific message. The programmer is still working on submitting queues without fences. That's what the comment suggests. So since that's work in progress, we don't want to flood our message log with these messages. So we check out this message string. If it matches, we just return false. And then if it's not a warning or an error, we bounce out to this else and just return false, and nothing happens. So we're going to ignore anything else that happens. And then finally down here, we've got a text string with called message that's filled up with the text we want to print, and depending on the operating system, output the message. So it's pretty simple. So as promised, we're going to talk about how to activate individual layers. This is also easy to do if you don't want the entire stack of 7, and there's various reasons for that, which we'll discuss a little bit more later. All you have to do is specify the individual layer names. So I think on Windows, let's see. So it's a colon separated list on Linux and semicolon separated on Windows, I think, but you can check the docs to make sure. Or programmatically, it's just a list of layers. Okay, so now it's time to kind of hang on to your hats here because we're going to jump into a lot of detail and a lot of code. So stick with me, and hopefully you'll enjoy it because it's there's a lot of detail, but it's pretty neat stuff. Before we dive into the code, though, we want to take a quick reminder about how layers work and how they hook API calls. So we have our application, we have our loader, and a couple of layers, sample layers, and then this is a driver, a available client driver, it was ICD. So in this case, the layers are hooking up VK destroy device, so it goes through the loader, and both layer A and layer B for some reason are interested in destroy device, and then that gets passed on to the driver. The other two API calls here, which are just samples, layer A and layer B don't really care, so they don't hook it, and those go straight from the loader down to the ICD. In general, the validation layers hook nearly probably all the API calls at some point. There are some specialized layers that would hook far fewer API calls. The only one that springs to mind is we have a utility layer called screenshot, and as you can imagine, that one just it doesn't care about anything except say the presents. So it would hook a present, which is sending the frame buffer to the display, and it would hook that and grab the contents of the frame buffer. So the screenshot layer is an example of one that doesn't hook very many API calls, but it's not a validation layer, so we won't talk much about it. So where does the source code come from? Just a quick orientation. Since we're going to be looking at a lot of code in the next few slides, I just want to tell you where it comes from. One place you can look at it is in the SDK. There's a source layers directory in the SDK. You can also go to the GitHub repo, and there's a layers directory in there. And one thing to keep in mind too about a lot of this validation code is a lot of it is generated with Python scripts. A lot of that's done for convenience because it's kind of tedious to write out stuff for every API call. And also there's a lot of information in the specifications XML file representation, which is used to, all that's leveraged to generate code as much as possible. So the downside to that is that you need to run something to generate those files. In the case of the SDK, LunarG has generated those files for you, and they are part of the SDK. But if you're looking at the GitHub repo and want to look at the generated files, which you'll find out you'll have to do very shortly, you'll have to actually build the repo, or at least run the Python scripts for it. So first layer is the threading validation layer. Its purpose in life is to make sure that any actions that are using objects are not violating threading restrictions. So there's some language in the spec which is quoted here: host access to object must be externally synchronized. So that shows up in the Vulkan spec a lot whenever these things need to be guarded as far as threading goes. So a good example is the VK command pool. Everyone knows that Vulkan's attractive to a lot of people because you can record command buffers. You can record many command buffers at a time using multiple threads. But one thing that you have to watch out for is that you can't have more than one thread recording to command buffers that come from the same command pool. So that's what this is all about as far as synchronizing host access. So if you wanted to do multi-threaded command buffer recording, you would need to use multiple command pools. So this is, could be a mistake an application developer can make, and that's why the threading validation layer is here, is to check for problems like that. And in general, the threading validation layer, if you know that your application doesn't do multi-threading, you could deactivate it. But leaving it in place, I don't think hurts too much because there's really not a lot of overhead. So here's a snapshot of the complete code for one Vulkan API call. We're going to pick a lot on the command set viewport call. We'll use that as an example throughout a lot of this presentation. And really, we're going to dig into this code a few lines at a time, but one thing I wanted to point out here in bold is these comments were actually generated by the code generation steps. And this is kind of a signal that says, oh, hey, okay, we've got this section of the spec covered. It actually kind of like echoes the spec language into the code. So we now know that we've got coverage for this part of the specification by sticking these comments in the code. So let's just zoom in on a few lines. One of the common patterns that you'll see throughout the validation layers is this code which gets the tracking data that belongs to the layer. Typically, each layer allocates some data structures that are attached to various objects, and those data structures are used by the layers for tracking the layers, tracking that object state for the layer to use as part of the work that it does to determine whether things are valid or not. And so you'll see this a lot in various forms throughout this code. Then the next thing we do is we first have to decide, do we have to do multi-thread checking here? In other words, is the application multi-threaded? And so that's delegated to this little proc here called start multi-thread. And I'm not going to show you that code directly, but because it's really simple, and I just wanted to explain conceptually what it does. There are two flags that are visible to all the threads. And basically, when a thread enters this function, it will turn on a flag that says, hey, I'm inside this API. Of course, it turns it off on its way out. But if a second thread enters while the first thread is still in that function, it sees that the API flag is still turned on. And so, oh, there must be two threads in this code. That means we must be multi-threading. So it sets a second flag called multi-threading present. And this flag is sticky, and it doesn't go off while the process, until the process dies. And because once the application starts multi-threading, you can't assume it will ever stop. It's just a multi-threaded app from that point on, which is a good guess. And then finally, there's an optimization that says, well, if the multi-threading present flag is already on, then we'll just return true because there's no need to check the other flag in that case. Anyway, hopefully that's a pretty clear concept. In any case, take it for just believe me that this thing will tell us whether we're multi-threaded or not, and then it'll set the thread checks boolean that says, oh, you need to check for multi-threading. So in that case, we call start write object, which is another rather large proc that I don't really want to display here because it's pretty big. But its basic role is to keep track of the reader and writer counts for an object. So anytime this thing is called, those counts are updated according to what the command is. And if there's a conflict with the number, if the number of concurrent readers and writers is not by the spec, then it will emit a validation error. So in this case, we're talking about having more than one thing writing commands to a command buffer, so it's a simple check to make sure that the number of writers is not bigger than one. And then it'll throw a validation error if it's the case. Next thing is, this is again common code to call down the next layer in the chain. If you have multiple layers activated, it could be a layer. If this happened to be the last layer in the stack, it would just call the driver. So it's calling the next layer or the driver that's in the chain. And in general, too, the multi-threaded layer, the threading layer doesn't really skip calls. It always goes ahead and calls because sometimes threading validations aren't particularly fatal. And then finally, after we're done with the call down the chain, we need to clean some stuff up. So we update the reader and writer counts to indicate that we're leaving. And then we also turn off the in API flag and finish multi-thread. And the else this is inside the else because there's no sense turning it off if we already know we're multi-threading. So that takes care of the threading layer. We'll move on to parameter validation. And this is fairly simple. It's stateless, making stateless API parameter validation. We look for valid usage and device limits. And this layer is up near the top. And it's good to have it near the top of the layer stack because you want to catch anything like unallowed null pointers and other fundamental problems that will mess things up later. Like, for example, the layers that come after this, they're not coded to check for null pointer before dereferencing them. In fact, a lot of drivers don't do that either. A lot of drivers are quite happy to dereference a null pointer if you pass one down. And drivers assume that Vulkan applications are correct. So if the spec says that a pointer cannot be null, it better not be. So if the driver makes that assumption, it won't have the code to check it. So that's why this is a good thing to put near the top. It's also a good thing to address with high priority. So if you do have errors, like if the parameter validation layer says, hey, you have a null pointer, that needs to be fixed right away. Otherwise, anything below you isn't going to work very well. So we'll look at the code again. This is a human-coded program. It's not machine-generated, and we'll just take it apart bit by bit like we did before. Again, the bolded code, that's grabbing the layer tracking data. And then here we're calling a helper function that does the actual checking. A lot of this code has been kind of refactored so that the detailed parts are put off into helper functions, and then you might see calls like it's in bold right now that repeated several times with different helper functions, so it just looks a lot cleaner and it's easier to follow that way. So that looks kind of nice. Another important concept is you'll see the skip call variable used a lot, and that means it's usually set to false, which means don't skip the call to the down the chain to the next layer or the driver, and it's usually set with one of these or equal assignments, so that each of these helper functions have a chance to set this to true if they find something that's so horribly wrong that forward progress can't be made, so we should skip the call. But we're going to, before we look at this helper function, we'll just finish off the rest of the functions so you can see what it looks like in total. So if everything's A-OK, in other words, skip call is still false, then we call down the chain to the next layer or the driver. So let's take a look at the actual helper function now. So this helper function is used a lot to keep the top functions short and to reuse this logic in a lot of places. In this case, it's kind of a wrapper. It's just calling a very generic validate array function. And so what's happened in the Vulkan API, you see a pattern quite a lot in the APIs with the parameters. You'll see a count variable and then a pointer to objects, which would be a pointer to an array of objects that are if you have 5 for count, there would be 5 objects there, for example. So the spec has a lot of language in it that says, okay, you have to have at least one viewport if you're going to call VK command set viewport. And so we have this it's very generic function to validate that kind of construct. So we pass because it's very generic, we have to pass a lot of text strings here to say what's happening. But this VK command set viewport is the name of the function that we're validating. These are the parameter name, actual themselves, and then these two true parameters indicate that both the count and the viewport have to be present. So validate array is just another utility, and we'll go look at a piece of that right here. This code can also be found in I believe this is a human-coded file, and so validate array looks like this, and this is just part of it, and this is just the part that validates the count parameter. So if it's required and this was set to true by the caller, and if it's 0, then we better log a message that says, hey, you can't have a viewport of 0 here, or viewport count of 0. And another thing you'll see a lot in the validation messages is a function called log validation layers. Is you'll see a function called log message, which is really just a wrapper that calls the debug report callback. Okay, this slide's kind of busy, but it's kind of important. If you look at the spec, you'll see these sections called valid usage, and in particular, if you look it up for the set viewport command, there's a little checklist there of all the items that have to be considered for valid usage. And so I made it a little like a report card here to check off the ones that we know, the ones that we know we've got covered so far. So the command buffer being valid is kind of a side effect of running the code we looked at before, the part that looks up the tracking data. So if we successfully looked up the tracking data for the layer, then we know the command buffer is valid, so that worked out okay. We saw code that checked the viewport parameter. We didn't really look at it in the validate array function, but there was code there for that. And then viewport count we looked at directly. So we know that these three are covered. The rest of them aren't covered yet. And so some of these are going to be covered in the core validation layer, and some things just simply aren't implemented yet. It's just a matter of people getting the code done, and it's just one thing to be aware of with the validation layers is that they're not 100% complete yet. But ideally we get to the point where all these valid usage items are checked off. Okay, onto the object tracker layer. So the simplest way to think about this one, it's just a layer that makes sure that any objects that are needed actually exist. One simple example is, again, if you're going to record a command in a command buffer, the command buffer better be valid. So the code that runs for all these, there's about 50 or so of these VK command functions that put commands in the command buffer. They're all going to kind of do the same thing and just make sure the command buffer is valid. There's some more interesting examples like VK destroy buffer. The parameters for that are the device and the buffer. You want to make sure both of those are valid objects. But it's also good to check to see if the application tries to destroy a buffer twice, because some drivers will crash if you try to do that. So the object tracker keeps track of that kind of thing. And again, here's another big look at the code, and we'll pick it apart again. This is in layers object tracker.cpp. And the code looks like this. I think this is all of it, actually. No, it's not, sorry. But these are just the first few lines. So these validate calls, these are the ones I talked about that just simply make sure that buffer and device actually exist. And they will emit error messages or validation error messages if those objects don't exist. So that's one good thing. And then the next thing, the bolded code here, this is kind of a housekeeping routine that's inside the validation layers. This destroys the tracking data that's associated with the object. And it has the key where if you try to destroy it and it doesn't exist, it won't crash, but it will complain by issuing another validation error. So if you come down here and you try to destroy a buffer twice, you can expect these kind of messages coming out of object tracker. There's the first one that just says, oh, the buffer's not there. It really should be if you're going to destroy it. And then secondly, the thing that tried to clean up the tracking data complains and says, oh, I don't have any tracking data for this buffer object. Made it in the first place? Has it been destroyed, or what's going on? So anyway, we will continue to go on down the chain. This code here, destroy buffer, will do that, and there's a chance the driver might crash. Again, the value here, if the driver crashes, it's bad, but the good news is you've got two messages really close to the time of the crash. It allows you to associate double free with the crash, and you can hopefully resolve it quickly. Image validation layer, as we kind of hinted before, it kind of does the same type of work core validation does, but just with a special focus on interest. So, good news, we're not going to dig into any code here because it looks the same as any other core validation code. And again, as I said before, we expect this to get merged eventually anyway, so we don't want to get too into the details here. So core validation layer is really important. It's the key validation layer for everybody. It checks in 4 major areas, and it's distinguished from the, say, parameter validation layer because it's looking for consistency and correctness across Vulkan objects. So there'll be a lot of making sure that, okay, this object's in the date, so it's okay to do this here, et cetera, et cetera. So it gets a little bit more complicated than something like the parameter validation. And we're going to look at viewport again. So this is a human written function, and there's a lot of code here again, the usual stuff to get the tracking data and get, in this case, information for the command buffer. The add command function is probably the most interesting thing here. We're not going to actually look at it, but it just does some basic command buffer validation, like is the command buffer in recording state and is it capable of accepting, is it graphics capable? And the rest of the code is kind of like bookkeeping for the validation layer. It's putting a mark on the wall saying, okay, the viewport's been set, and here's the viewport mask, et cetera, et cetera. If everything's okay, we call down the chain again to the next thing. So let's go ahead and look at our report card again and see if we've got any improvement. So the red and underlined lines show that the things that we've just been checking. Basically, the command buffer's in the recording state, and it must support graphics. So we were able to check off 2 more boxes, so that's good news. And you would expect if you look at the next 3, so how are we going to handle those? This first one looks like, oh, this is something we could handle in core validation because we need to compare pipeline state with with this. We need to make sure the pipeline state's correct in order for a viewport command to be used. And then there's also these checks against physical device limits. So these 3 things are candidates to add to the core validation layer for this particular command. And so we're going to step a little sideways here and take a peek at the set line width command, because this one actually has the draw state check in it, or the dynamic state check, I'm sorry, implemented. So let's take a look at this. So basically, we just make sure that we take a look at the pipeline state, and if the line width bit is not set in it, meaning that the line width isn't dynamic, then we'll issue a message. So, going back to Vulkan basics here, if in order to use a command in a command buffer to do something like set the line width, you have to set the pipeline so that the line width is marked as a dynamic attribute. And that's what we're checking here. We're making sure that the dynamic bit's on, which means that, oh, okay, that means it's okay to send down a command that changes the line width in a command buffer. And as the message says, it's kind of undefined if you do that, and could probably most likely will get ignored. So this is the type of thing that it's not going to be a fatal mistake, and it's unlikely to cause a skip as far as skipping the API call. It'll just make your output incorrect if that's the case. Another thing core validation does is shader checking. So this just makes sure that the current stage has the correct bit set in the range flags. And this one is really valuable for looking for leaks. The background here is that if you allocate memory objects on a device, and then later on if you go to destroy that device, you're supposed to free those memory objects first. Otherwise, you could potentially get a memory leak when the device is destroyed. So there's some pseudocode here at the top, which I just wrote it in pseudocode for compactness, but basically for each tracked memory object, you go ahead and get a pointer to the memory object's tracking info, which is called pinfo, and then if its size is still like 0, if the size is something other than 0, so it's been freed yet, which is bad because we're trying to destroy the device here. So then we print out this really helpful message that says, hey, this memory object hasn't been freed. You should consider cleaning it up by calling vk free memory and before you destroy the device. So a lot of hand-holding going on there, but it's really useful. So that's one way to help check for memory leaks, and that's here in core validation. And device limits is also pretty simple. Here it's a pretty straightforward check to make sure that when you create a frame buffer that the height and width and so forth are less than the device, or are not greater than the device maximums. And again, the error message is pretty straightforward. Okay, that finishes up core validation. Swap chain, it's again a lot like image. it's going to get merged in the core. In fact, I think there's some code in flight right now to get this work done, and it might be combined within the next couple of weeks or in the next SDK. Unique objects is an interesting layer. It's sort of it's not really a validation layer in itself. It's more of a utility layer that does this object handle mapping. And it's really meant to solve a problem. I think we talked about this a little, prior in this webinar, but just to touch on it again, there's nothing in the Vulkan spec that keeps drivers from returning the same handle for things like image and buffer, different classes of objects, because they can, by their context, keep those handles separated. But it causes problems for layers. And drivers can also reuse an object after it's destroyed. So to address it, the unique objects layer defines its own unique handles and returns those to the driver. So the applications shouldn't be affected by this, because applications don't build, because they're considered to be opaque, and you would never dereference them or rely on the handles in any manner. But if you took a peek at them and compared what the handles look like with the layers enabled and with the layers disabled, you might see some different patterns. Like, for example, if the layers are enabled, you might see some very small numbers coming back, like 5, 6, 7 for a handle, or 8 or 10 or something. Whereas if you don't use the layers, the handles might start looking more like pointers, because they might come directly back from the driver. So in any case, you're not supposed to look at those, but the handles do change. And all this works because the layers will actually unwrap the handles before passing them back to the driver, so the driver gets back the same handles that it thinks it gave the application. So this system works fairly well, but we discovered recently that for Vulkan extensions, it's a bit tricky, because if you write an extension that sends down that uses a handle that got wrapped, the validation layers don't necessarily know about that. So the reason in the world for Vulkan is that if you write Vulkan extension, you should really also make sure the validation layer has extra code in it to unwrap those handles before passing it to the driver. Okay, that basically concludes the deep dive into the validation layers themselves. Let's talk a little bit about what's coming. We also showed this slide at SIGGRAPH this past summer, and this kind of shows where we are right now. And we also had this part of the picture at the beginning of this presentation. Nothing too new here, but what we're going to be doing, as I alluded to, we wanted to, the future looks like we'll be combining some of these layers together, potentially all into one layer, which would be really convenient for a lot of people, and a lot of other reasons. Internally, it makes a lot of sense, because the tracking data can be shared much more efficiently, and there are other reasons to do it as well. But then you might point out, well, gee, if you make this all one layer, how do I do things like turn off the threading layer because I really don't need it, or I've done my parameter validation already, so I want to turn that one off, or the image validation is taking too long, so I want to turn it off, and you have those kinds of questions. So the answer to that is, although this will all be one logical layer, it will be built in a modular fashion, where there are these functional modules that do the type of checking that roughly corresponds to the old layer list. So that's pretty cool. But in addition to that, we'll be able to select these functional modules and essentially be able to turn them on or off, and possibly also have some knobs here you can turn that say how much work each of these functional modules should do. Like some of these tests, they can take order, m times n type complexity, comparing thousands of command buffers with thousands of fences or something, and so you get into some very complex and time-consuming checks in the worst-case situations. So for those time-consuming checks, and there's actually an issue open on the GitHub about this, you can turn the knob here and turn off that one test, for example, because you might be okay with, you might be convinced that you don't need the check because it's okay, so you want to turn off the time-consuming part of it. So there could be knobs here that you turn to have even better control over what the layers do than you do today with the separated layers. At least that's the goal. So we're wrapping this up. We're at the end of the slide deck almost. Mark Lobodinsky is one of our lead validation layer engineers here at LunarG. He'll be up next to answer any questions that have been submitted over the past few minutes, over the past 50 minutes. And I just wanted to recognize people who've been working on the layers. There's been a lot of open source contributions. We appreciate the pull requests, and a lot of work has been coming from engineers from LunarG and Google. So I encourage you to check out the GitHub repo, and it's one of the more active repos. Tons of issues flying around and getting added and getting resolved. So there's lots of activity there. And then finally, if you do nothing else, please just use the validation layers during application development. And if you find any issues, let us know. Pull requests are good. And then here are the links that I promised. We have a link to the LunarG website, where you can get the SDK. There's also documentation, and then there's the GitHub repo. And that's about it.
Okay, Mark, you are unmuted and you can take it away.
Okay, I don't see any questions on the list right now, so I'm just going to make some stuff up until somebody gets brave. One of the questions that's come up before is if you wanted to contribute to the validation layer work, how would you go about doing that? And if you can get on GitHub, you can certainly submit issues if stuff comes up, like we've already talked about, or if you want to add some valid usage stuff, or increase the density of the checks, or add some work in a new area, there's some shallow spots in the validation. You could just work with us through pull requests. We've had some great contributions over the last few months. People giving us a lot of help with swap chain flavors that we don't have here. Some things like that. So that's probably the best way, and it's a collaboration. So we go back and forth, and we'll take anything contribute. We're happy to incorporate into the layers. Let's see. Yes. So Marco's answering a question, or asking a question about enabling the validation layers for shipping applications. And although I think that there's probably some way that an application could block the layers, it's not really designed that way. I suppose it's possible. But you can use a layer settings file. Carl touched on this during the presentation. An application can control the value by using back. If you enable the layers, you'll get some default output, but you can, through the environment variables, validation layers, and then you can use the layer settings.txt file to control the output. So a lot of times as developers, that's what we'll do, because the app we work with don't call backs, or we don't have access to them. So we can still get validation layer output by using the settings file, and they kind of work independently. The application has full control over the output internally through the debug callbacks, but that's completely separate and independent from the control you have using the layer settings.txt file. Currently, the settings file has to be in the same location as the application executable. So there's no provision right now to locate it somewhere else and path to it or something like that. It has to be in the same directory, and that's where the loader will look for it. Yeah, we have had a suggestion before. This is for Peter's question. We have had a suggestion before for doing enums on the layer names, and that would be a good GitHub issue if it's not there already. We talked about doing that.
Hi, Mark. This is Kathleen. Be sure to read the question. The people in the audience don't have visibility to that.
Oh, I'm sorry, Kathleen. Thank you. So Peter's full question was that he saw that we could activate layers by specifying the names in an array, but he thought that was typo prone, and wouldn't it be a good idea to have an enumerated value for the layer names? And that's probably true. We could do that. We just haven't up to this time. Most people just use standard validation, which again I suppose could be an enumerated value, but that would be something we could add in the future. Let's see, I have a question here. What's a specific example where an application would work on one GPU but not another, and that would be caught by the validation layer? We see it's fairly common that people will write an application and because a driver or GPU combination work in a certain way, they may not pay attention to those things. So this comes up a lot and related to memory types or queue families. I think what is it? NVIDIA, their driver doesn't actually do anything with image layout transitions. They're all actually I could be wrong about that, but they ignore some of the parameters which other GPUs might be sensitive to. So the layers will call these things out as errors. If you try to use a queue family without making sure that the properties are compatible with the types of memory that your application needs, the validation layers will give you an error for that. And we try to these things come up all the time, so we try to make sure that those areas are covered. As Carl was saying, there are lots of areas in the valid usage portions of the specification which aren't covered, and we tend to give priority to things that people have reported. So if you guys spend or waste a lot of time debugging a problem, it's likely something that we could add validation for, and that's a good reason to submit an issue because we, as I said, we prioritize those over things we just pick out of the spec.
So to build on your NVIDIA example, Mark, yeah, you're correct. The NVIDIA drivers essentially treat layout transitions as no ops. So if you write an application and forget to do layout transitions completely, it might work on NVIDIA, but if you take it to another driver, it simply won't draw anything. And so that's one great example of the validation layers reminding you that you really have to code the layout transitions, even though the device you're working on doesn't need them.
Okay, there's another question here. If I'm getting validation errors I don't understand or think are incorrect, what advice can you give me? I would say there that there's actually an effort in progress right now to go through and clarify a lot of the messages. And this is particularly in regards to abbreviations and shortcuts that we didn't realize we were using here. But there are a lot of confusing messages. And I know that Tobin and Chris have gone through lately and have plumbed through some of the validation messages to tell you exactly which API they're coming from, or be a little more clear about how the error message relates to a specific. Instead of just saying you have an invalid transition, it will give you more information. If you run across a particular place where you can see this, just submit a GitHub issue, and we try to get to all of those in time. And fixing messages is pretty simple, so they're easy to get out of the way. Or you can do a pull request if it's easy. We prefer pull requests, but so here's another question about applications. Is it recommended that applications request specific specification or implementation versions of the validation layers to avoid unexpected breaking changes in future layer releases? Or it should be safe to just use the latest available version? In general, it's always safe to use the latest version. The specification as long as it's 1.0 for Vulkan, is going to be backwards compatible. And the latest version of the validation layers is for a given version of the header is always going to have the most up-to-date validation checks. Now, you could get into trouble taking the latest header version and then running it on well, that might work too. I don't know, but in general, you're okay using the latest ones. We try very hard not to have any breaking changes in the validation layers themselves. It's more of an issue with the drivers, and possibly the gray area here is extensions. If you if you're working on an extension, or if you have an extension that's not in the header yet, there can be some synchronization issues. But for pure validation, you should be fine using the latest stuff on GitHub. And often, if someone's running with an older version, we'll ask them to try the top of the tree, because a lot of, we're putting fixes in constantly and at a pretty rapid rate.
So there may be some concern too about, the guy at the question might be thinking, well, my application is running validation clean right now, and so I'm happy, but if I pick up a new version of the validation layers, then something could go wrong. And so there could be a couple reasons for that. One is there's a possibility that, well, first of all, if you get a new validation error, it may not necessarily break your application. It could be a warning or an error that might be harmless, but the validation layers are under constant improvement, so we may add new checks to the validation layers that expose latent problems in your application that the older validation layers weren't finding. So that's a good thing. That fixes some latent bugs in your application, and you can fix it up so that it passes validation again. And then there's also the possibility that new validation layers might actually, people make mistakes, and the validation layers could introduce, have a bug in them that will be a false positive, and so that's just something that you'd have to tell us about.
Right. We have a close relationship with some major game developers, and before every release, we'll run their latest version of the app against the latest version of our validation layers, and it's pretty common that new things will crop up, and they'll have to go fix them, just because new checks have been added. There's another question here. Let's see. Could you speak about how validation layers work in Android? Is the goal to have them work exactly the same? For example, the standard validation meta keyword doesn't seem to be defined yet. As far as the layers go, our goal is to make them work identically. The layers themselves are exactly the same. That said, Android, for obvious reasons, uses a different loader than the desktop loader that's included in the SDK. So the way, and there are other people who are much more knowledgeable about this than I am, but the way that layers get loaded in Android is different than loaded and handled in Android is different than on a desktop system. Maybe Tobin can shoot me a message, but I believe that the layers have to be included as part of the APK, and there are some other restrictions about the way they get loaded. But on the desktop, since we can change the loader at a much higher frequency, we have a little more flexibility about naming things and using JSON files, for instance, things that would have security implications in Android. So the layers themselves are actually identical across those platforms, but the way they get loaded is a little different. So there's no standard validation meta layer on the Android side. They have to be loaded explicitly. But this also ties into our goal of, Carl talked a little bit about how some of the layers were coalescing, and eventually we would like to get to where we just have 1 or 2 layers, and that should minimize those differences even further. Let's see. Yeah, I had another thing I wanted to mention. This is a kind of a personal preference, but there's a layer in the Vulkan tools repository called the API dump layer. And right now we have a couple of different kinds of layers. There are validation layers, which you talked about today, and utility layers. The unique objects layer is actually a utility layer. The API dump layer is a utility layer, which will, just like the other layers, you could control the type and location of the output, but it will print out each API call and the parameters that are included in that call. It works for multi-threaded applications, and it will create a huge amount of very detailed data. This is useful for many reasons. One of the things that we use it all the time for is the layout transitions. These can be hard to track down, and the validation layers only, at this time, only have the ability to tell you that they're expecting one layout and you're currently in another layout. But the API dump layer is a good way to dump your application up to and including the the validation errors can be included in the same output stream, and then you can trace back using image handles and command buffers and queue submit handles and things like this. You can trace backwards and see every transition and find out where you've got an extra one or where there's an assumption you made that was incorrect. So we do this all the time. It's pretty frequent that someone will create an issue and say, hey, I'm getting this validation error about a layout transition and I know it's right. And so we don't know. We'll have to, we have to get a hold of their application, and the best way for us to do that is to generate an API dump and trace backwards and see how they differed. And so far, the mobile guys have done a fantastic job on the layout transition validation, and it's almost always correct. We have had a few corner cases, and I'm sure there's some more, but it's very robust. So, like I said, that's a really good tool for a lot of things like that, and will help you visualize what's going on in your application. It's actually going through a refresh right now, and should give you even more control about the type and frequency of data that you get. Let's see. Another thing I wanted to mention about layer output is Carl mentioned the application debug callbacks, and there's the layer settings file. It used to be that if you loaded the layers and there were errors being generated by your program, that you couldn't see them. We've made a change a few SDKs ago so that even if you don't have a debug callback, or if you don't have a layer settings file, you should still get the error output at least to standard out. So as long as you have the layers loaded, you should be able to see something. Sometimes it's a little tricky on Windows as far as where standard out goes, but there's also an option, which I think is included in the default on Windows, so that that output will also go to output debug string, and you can see it inside Visual Studio.
Mark, that layer settings file, is that the vklayersettings.txt file?
Yes, Kathleen, thank you. It is.
Did you see that we have a question from Jeffrey Giuliano concerning that file?
Yeah, I touched on that earlier. Right now, the text file does have to be in the current working directory or the directory where the application is. If you don't have access to the, you can't change the application to add a debug callback, which is the preferable way, and there's no way for you to put the settings, the layer settings text file into the working directory. Your only option at that point is just to lower the layers and have the debug go to standard out. I guess that would be a good thing to create an issue for. I don't know. There's some guys here who are who would much better be able to address this issue as far as being able to locate that somewhere else. I'm sure it's possible, but it's not a feature we've added yet. Let's see.
Jeff has a follow-up question to that. He says, when is vklayersettings.txt read? Is it one time during the initial layer init?
Yes, at layer init time, the text file is read in and put into a local database. And from that time on, the file's not read anymore. So it only gets read at the beginning, and all those settings are saved off. I think we talked about my list of issues here. I don't see any new questions. Carl, did you have anything you wanted to add or any areas you wanted to clarify?
There actually is one more question here from Balaz, if I'm pronouncing that correctly. It says, activating custom layers would require a string name array unless they have to be added to a global enum, no?
Yeah, the idea, I think the proposal for doing that was to, if we had enums, the enums would just, we would define an enum type, and the enum type would essentially be an index into a string array that would be used by the loader to find the loader to find the string name rather than having the application code the string. Yeah, it's. I think if we were to implement that, that's probably something that we would do it along those lines. I don't know. We did. I think we did consider, as Mark said, we did consider doing this to somebody very early, like back when Vulkan first went public, made this request, and we considered it, but then had to work on other things. So, and plus the layers were still very volatile at the time, and we were hesitant to define enums and have them change on us. So, in any event, we'll look at that again and figure out the right way to do it. Someone here at LunarG actually made a suggestion for something that we should mention, and that if you have a device that uses the NVIDIA Optimus extension, which often appears on devices, I think, that have multiple GPUs, say an Intel graphics core and an NVIDIA graphics core, that's a layer that you might want to disable before attempting to do validation with the validation layers, because that Optimus layer will change things as the Vulkan API calls go through it, and it ends up being at the top of the stack, and so it can change things from the point of view of the validation layers. So that's just something to look out for.
All right. Are there any other questions? Or Carl or Mark or Karen, do you have anything to add? All right, then I guess we can call this baked. Thank you, everybody, for coming to our webinar. We are going to be posting this video as well as the speakers, a PDF of the presentation on the website. An email will go out to you shortly that has the information of where you can get that. Also in that email will be a link to a very, very brief survey. We would really love your input on how we can improve our webinar program, so please do complete that.